Hello, in this video we will learn how to graph the five basic polar graphs such as the limacon, rose curves, circles, and spirals. Also, we will learn how to we will learn two different methods for graphing each polar equation such as transformation and the table of values. So let's kind of review limacon. You probably learned this in pre-cal. So how do you know if you have the limacon if it starts with r equals a plus or minus b cosine theta, or r equals a plus or minus b sine theta? And limicons looks like these heart graphs, right? They're not exactly a rose, but yeah, they look like these. So how do we graph it? So let's look at example one. It says graph r equals 1 plus 3 cosine theta. So what we got to do is figure out our a and our b, right? So it looks like our a is 1, and my b is 3. And because since b is positive, we will focusing on the left side of the graph. So since this b value is positive, we'll be focusing on the left side. Okay. So then what we do is do the a over b. So my a is 1 and my b is 3, and 1/3 is technically less than 1. So since 1/3 is less than 1, we have what's called an inner loop. Okay, so it's going to be on the left side, and it's going to have an inner loop. So it would look something like this, or roughly look something like this. Like that. Um, but if you're not sure, you can always make a table. So what do I mean by a table like this? Your x will be your theta, and your y will be the radius. For example, if you use the x value 0, it's going to be r equals 1 plus 3 cosine of 0. And that gives you 1 plus cosine of 0 is 1. Wait. Yeah, this would give you 2. It would spit out 2. And if you use pi over 6, it would be r equals 1 plus 3. And then we know that the cosine of pi over 6 is uh, radical 3 over 2. So that's going to be 1 plus 3 radical 3 over 2. Okay. And then you would plot that and you would somehow roughly, you would get this. So this is more of a detailed approach. And then this is more like an S, just like a good foundation. Okay. So let's move on to example 2. I'm not going to make a table on these examples because you should know how to do these, but I just want to there's kind of like, for example, example two, we got to graph this. Uh, so our A value is 1 and our B value is 3. And then we have a minus. So our A value is 1 and our B value is 3. And then there's a minus right in the middle. So what that means is we will still have an inner loop. And we will be on the negative x-axis. Okay, so it would look like this. Okay, it would look something like this. You could make a table to make it look more detailed, but I just want to, yeah. Okay, let's move on to the next example, example 3. We have r equals 2 plus 5 sine theta. So your 2 is your A, your 5 is the B. So A over B is 2 over 5, which is still less than 1, so that means you have an inner loop. And this time we will be on the positive y-axis. Okay, so it would look something like this. Okay, so it would look something like this. Okay, let's move on to example 4. R equals 2 minus 2 sine theta. So my 2 is the A and my B is the 2. So it would be 2 over 2, which is 1. And it would look like a cardio, but it would look like art. Just like this. Yeah, it would look something like this. Okay, let's look at example 5. Um, we have r equals 4 plus 3 cosine theta. Our a is 4 and my b is 3. So a over b is 4/3, and that is greater than 1. So it would look something like a bean. Okay, it would look something like that. Now let's move on to example 6. We have r equals 5 minus 3 sine theta. So my a is 5 and my b is 3, which is greater than 1. So it's going to be negative on the y-axis, just like this. Just like that. Okay, so now let's move on to rows, curves, and circles. So rows curves are would look something like this. You can have one petal, four petals, etc. So you know you have a rose curve when you have an equation that's in the form of r equals a cosine times parentheses n times theta, or r equals a sine parentheses n times theta. And you have a circle when it's r equals a. And a is the length of each petal. And then n is equal to the odd number, or also the number of petals. And if your n is an even number, it would be 2 times n number of petals. And then sine or cosine is on the x and y axis. So sine is, yeah. And then r equals a is a circle at the origin. Okay. So graphing a rose curve. Let's say you have r equals 2 times cosine of phi theta. So we know it's a petal, I mean a rose petal, and the 2 represents the length. And then the 5 is odd, so you have 5 petals. So this is 5 is odd. We're gonna have 5 petals, so it's gonna look like this. The length is 2, and then 5 is odd, so 5 is 5 petals. So it would look like this. So 5 petals would look like this. And then the length of the petal is 2. Okay. So this is what it would roughly look like. Okay, let's move on to example 2. So r equals 3 times sine of 2 theta. Um, so what do we know? 3 is the length. And then it's 2 is an even number. So even is 2n petals, or you're gonna have a total of 4 petals. And then the length of that each petal is 3. So it would look something like this. Okay, 4 petals, and then the length of each petal is 3. Let's move on to example 3. So we have r equals 4 sine times 3 theta. So what would be so 4 would be the length, and 3 is odd, so we have 3 petals. So the length is 4. And then our 3, since 3 is odd, we have 3 petals. So it would look something like this. So this length is, each petal is 4. Yeah, so that is, yeah. So yeah, this is just a rough. If you want it really nice and neat, you can make a table. Let's move on to example 4. So 2 is the length, and then 2 is even. So it's going to be 2n, which is 4 petals. So it would look something like this. So yeah, this length is 2, this length is 2, etc. Okay, move on to example 5. So 9 is our length, and then this is 1. So 1 is odd, so it's just going to be n. So 1 petal. So it would look something like this. And then the length of this petal is 9. Okay, let's move on to example 6. So r equals 3 times sine theta. So the length is 3. And then our n is 1. So it's just 1 petal. Wait, so you understand this will be on the y-axis, and then the previous one, why is the previous one on the x-axis? Because cosine is x, right? This is related to cosine, so that will be on the x-axis. And ours has a sine, so it's going to be on the y-axis. So it would look something like this. Okay. Okay. Um, so yeah, that wraps it up for this video. Uh, Next will be tangent line and polar coordinates. So we'll stop here.